All right, so this is lesson 13, and today we're going to cover two lessons. So we're going to do 13 and 14 today. And so 13 is plotting with Matplotlib, which is the core plotting library in Python. And then we're going to do, in lesson 14, we'll do plotting with Seaborn, which is kind of a wrapper around Matplotlib that makes a lot of plotting applications a lot more straightforward. So first thing we're going to do is go to lessons here, and we'll start with lesson 13. Okay, and then copy that URL, open up the terminal. We'll go to the SIO209 folder, lessons, curl-o, and then download that lesson. And then we want to go back to the lessons. And for lesson 14, we'll download that now too. There are, actually let's not. Let's wait. I'll keep it separate so that if anyone does just 14 by itself, they won't get confused. So we'll just start with 13 for now. We're going to source activate Python 3. Jupyter Notebook. And there it is. So we'll open that up. And finally, we'll just go to cell, all output. We'll clear all the output. And then I'm going to toggle that head bar. Okay. So this is Introduction to Matplotlib. This is based on a notebook by a guy named J.R. Johansson. And he had made this really great tutorial that I felt like I could tweak a little bit, but I couldn't do anything better than what he had done. So I'm going to use his tutorial for this lesson. And I think it does a really great job of really highlighting all the main features of Matplotlib. So the first thing that we want to do when we're plotting in a Jupyter notebook or IPython notebook is we have to make sure that the plots that we generate, we want to see them show up in our notebook. And so we use this magic command called Matplotlib inline. So it's just a %, no space, Matplotlib inline. And what that's going to do is allow us to see the plots that we generate. They'll be embedded in the notebook instead of it trying to open a new window or something. So Matplotlib is this graphics library, this plotting library, where you can generate 2 or 3D plots for making scientific figures. It's easy. It supports LaTeX for formatted labels and text. Gives you control over every element in the figure. You can generate all kinds of different formats, including PDF, PNG, etc. There is a graphical user interface, although we won't cover that today. And there's more information at this link here. So there's 2 ways we can use Matplotlib. There's a part of Matplotlib called Pylab, which is a kind of Matlab emulator. If you're very familiar with Matlab and you just want to do something really quick, you might find that using Pylab is useful, and we'll cover an example with that. However, for most purposes, you want to use the Matplotlib pyplot module. So this is a submodule of the Matplotlib library called pyplot, and typically we'll import this as plt. And from there, then you can just type plt.plot or plt.scatter, etc., and do all the things you want to do. So we'll execute these cells. So we have both all the Pylab functions in our namespace. This is mostly for today's lesson. I don't typically use this package, but we'll see some examples. And then we're also going to import Matplotlib pyplot as plt, and we're also going to import NumPy. So, as I said, the easy way to get started with Matplotlib is using this MATLAB-like API or application program interface called Pylab, and it's designed to be compatible with MATLAB's plotting functions. So if you're familiar with MATLAB, you'll find this very familiar. So for example, we can create an array with this NumPy linspace function, and then create a second array, which is that array squared, the values in that array squared. And then to make a plot, we use this figure command, which is part of Pylab. Actually, all of these commands are part of Pylab. We make a figure. Do you have a question?
Yeah, so I'm getting an error in the very first cell.
Yep. What's the error say?
It just says there's no module in Matplotlib.
Okay. So if you're getting the error that says there's no module, so that means we need to install the package. So it's possible we haven't done that yet. So what we can do is we can go back to the terminal. Let's type Command T to open up a new tab, and then we can type source activate Python 3. So we want to make sure that we're in the environment that we're using. We could have done this using a terminal in the notebook as well. So then we're going to do conda install matplotlib. Which gives me a chance to eat my bagel. Okay, so if you're like me, you already have the latest version of Matplotlib installed, so nothing happened. But did that work for you? Okay. And did you try to go back and rerun those cells?
Yeah.
Okay, great. So we're gonna create a figure, make that plot. So it's going to be y versus x. So just a standard two-dimensional plot with a red line. The x label we'll just call x, the y label we'll call y, the title will be title, and then we will show the plot. I believe this should work. Yeah, we don't really need this in the notebook. But this is a very basic example, but you can see it generates the plot as we expected. Yeah, no, because we're in the notebook environment and we did Matplotlib inline, we don't need this show. I guess I'll.
What is some features that Matlab has on each sheet here? Try the annotation, right?
You tried to annotate your plot and it didn't work in the notebook?
Right.
Did you use the text, the Matplotlib text function, or?
Because for for Matlab, we just use annotation.
Oh, you shouldn't. Sorry. So some of the MATLAB functions don't work here. Yeah, of course. Yeah, it's not a fully functional MATLAB emulator. It's just, it gives you some of the basic things. Yeah. We also have MATLAB style subplots. So we have this too in the fully functional Matplotlib, but just using Pylab, we can say we want a subplot with 1 row, 2 columns, and then this is plot number 1, and then we can plot to that one, and then we can issue the subplot command again, 1, 2, 2, and then it will generate the second plot where we've just switched the x and the y and changed the color and changed the marker from a dashed line here and then a star line here. But for most of the rest of the examples, well, for all the rest of the examples, we'll use Matplotlib pyplot. So this is a Matplotlib object-oriented API, and has a number of nice features. So in most cases, in most cases we will use a figure and an axis objects to control what we're seeing. So you can think of the figure as the whole figure, the whole image, and then axes are multiple axes in that figure. You can have multiple axes in a figure. So one example would be subplots, where you have this is an axis, or this is a set of axes. This is another set of axes, and then this whole thing is a figure. You can also have one axis inside another axis. You can do a subplot like that. You can superimpose them. You can do all kinds of things. We'll see. So when we create a figure using Matplotlib, this creates a figure handle or figure object that we can save and then do things with. And one way we can add axes is to use this add axes function on the figure object with these dimensions. And then we can then issue the plot function on the axes object. So if you have multiple axes, you need to tell the program which axes you want to plot on. Right? If you have multiple axes, it could go on any of them. So the plot function and the other plotting functions are issued or are functions of the axis object. So here we are creating this dimensions or the positioning of these axes, and then plotting y versus x with a red line, and then similarly we're setting the x label and the y label, but everything is on this particular set of axes, which as you'll see in a minute is important to specify because you might have multiple axes. So here we're going to create another figure, and we're going to add axes twice. And so this list that occurs when we add the axes, as it says up here, specifies the position from 0 to 1 of the left and bottom of the axes, and then the width and the height. So this is going to go from 0.1 to 0.9 because we're adding 0.1 and 0.8, and same with the width and the height both. So we're creating a one plot, and then we're creating a second, or excuse me, we're creating one axis that takes up most of the figure, and then we're creating a second axis that's inset in there. And then on the main axis, we're going to plot something, and then that's called axis 1, and then on the inset axis, this should be called inset, we're creating a second axis, or yeah, second axis. So here you can see the result of that. And so there's a number of things you can do to create these kind of objects. Now, there's a really handy function that we will use a lot called subplots. So what we can do is anytime we create a figure, we can just create it using this subplots function. Even if we only have one axis, it's a handy function because it allows us to set up. We can place some various arguments in here, so we can, or attributes. We can say the figure size is going to be this, and we can also say if there are subplots, how many rows and columns we're going to have. So this is going to be 1 row, 2 columns, like we saw before. But even if we have, and the thing about subplots is that it will create both the figure object and the axis object. So we can call these anything we want. Sometimes you'll just use AX instead of axes, and then again, when we're calling this plot function, it's called within the axes. So here we're typing axes.plot xy, and then a red line, and then the same kind of labels. So if we wanted to do subplots this way, we say again we're creating this fig and axes objects using subplots, and here we can say number of rows is 1, number of columns is 2. So then the axes object will be an array with two axis handles in it. I'll show you that in a minute. So we have axes, and then just like we do with a list or arrays, we can index that array to get just the first plot, the first subplot, or the second subplot, or the first axis or the second axis. And the first one is going to be index 0, and the second one will be index 1. So when we execute this one, we see that, just ignore this text here because this we can suppress the output using that. But the main thing is that you see that we have 1 row, 2 columns, 2 subplots, and this one has a red line, this one has a blue line, so R and B, which is Matplotlib shorthand. I changed the label slightly and the title slightly, but you can see how they function. So if I show you, yeah, so if I just type axes and hit enter, I see that's an array, and it's an array of length 2, and each element in that array is a Matplotlib axes object. Now, going back to the plotting aspect, so you can see here that the axes labels are overlapping here. And ideally we would want that to be spaced better. So one thing we can do is use this function called tight layout, which is a function of the figure object, not of the axes, because the figure considers all the axes and how they relate to each other. So we can call that function after we plot. And also I wanted to show that because axes is an array of axis handles, and technically it's axes, right? Because an axis is just x or y, and if you have an xy coordinate plane, that's multiple axes. But so what we can do though is, because axes is an array, we can iterate or loop over that array, and so for each axis in that axis we're going to plot something. So in this case everything will be the same, but the other difference is that using this fig tight layout after we, so if I had commented this out, you can see there's the overlap is there. If I remove the comment, now I get better spacing.